Hi everyone, my name is Ivan Del Vecchio. I am a postdoctoral researcher at the University of Zagreb in Croatia. My research focuses on the connection between galaxies and supermassive black holes. You may have already heard about supermassive black holes before. They are very massive objects, millions or billions of times more massive than our Sun. And they are believed to sit in the center of nearly every galaxy. Supermassive black holes can get bigger and bigger through a process called accretion. Imagine you have a galaxy full of gas, and this gas flows in towards the central supermassive black hole and can eventually get eaten by the supermassive black hole, which increases its mass. During this accretion process, supermassive black holes can sometimes shine very brightly, even brighter than the entire galaxy. When this happens, we call them active galactic nuclei, or AGN. We know that AGN are not all the same. There are different types of AGN. We have AGN shining in the X-rays or infrared, we have AGN shining only in radio, and we call this radio AGN. But why so different types of AGN? Well, we are not yet sure why, because in order to understand how AGN work and how they change with time, we need to study large samples of them, and more importantly, also different cosmic epochs, in order to track how they have evolved through the cosmic time. This is one of the reasons why we carried out this new radio survey called the VLA-COSMOS 3 GHz large project. This is, so far, the most sensitive radio survey ever conducted over a well-studied patch of the sky called the Cosmos field. This survey allowed us to detect for the first time thousands of radio AGN back to the far universe, to the very distant universe. This is very important in order to study how these sources have evolved throughout the history of the universe. In a recently published research paper, we studied in great detail thousands of radio AGN and also the galaxies that these AGN live in. Interestingly, radio AGN were believed until now to reside in the most massive galaxies only, with little or no formation of new stars at all. However, we see that seems to be only partially true. What we found is that while in the present-day universe, radio AGN seem to prefer to live inside big galaxies, in the distant universe they seem to prefer to live inside smaller and smaller galaxies. And intriguingly, the behavior displayed by different types of AGN, say shining in the X-rays or infrared, turns out to be completely different. So our results seem to suggest a connection between the type of AGN and the mass of the galaxy that these AGN live in. This connection can make sense, because the more massive the galaxy is, the more gas it might have, and the gas can eventually influence the feeding of the central supermassive black hole. So our results can be very important for advancing our current knowledge of the connection between supermassive black holes and the galaxies that they live in. Thank you very much for watching.